Thank you, Mark. Good morning, everybody. How are you? How are you all doing today? I can see people all the way in the back, and Mark was telling me there's 3,600 registered attendees and more people coming through the on-site registration. So every year I'm here. I've been here. I've been coming to OCP for the last 6 years now, and every time the audience keeps growing, the contributions keep growing. So it's really, really good to see all that. So let's get into today's talk. Uh, First, let's take a quick look at the history of Microsoft at OCP. Microsoft joined OCP in 2014, and since that time, we made several contributions in lots of areas: rack scale design, security, networking, and even solid-state storage. But what we will announce today takes us beyond all of these previous contributions. I believe when you see what we'll announce today, you will agree that it takes OCP in a new direction in terms of expanding the scope of what OCP can achieve through collaboration and innovation. So I'll hold on to that for a little bit until we get to that point. So first, let's take a quick look at two of the key initiatives that Microsoft has been driving in OCP. One of them is Project Cerberus, which is a hardware root of trust that was open sourced in November 2017. And the second one is Project Denali, which was open sourced last year at OCP about a year ago. So let's take a quick look at what has happened in the meanwhile in the last year. So on Project Cerberus, essentially Cerberus is a hardware root of trust that is used to secure the firmware on the platform to protect against supply chain attacks and runtime attacks. Over the last year, Microsoft and the rest of the OCP community has been working through a subcommittee on security. And the key contribution that has happened as a result of this open collaboration has been to extend the Cerberus specification to support, you could call it a master-slave architecture. What this means is, as you can see on this graphic, is that now the hardware root of trust domain can be expanded to the entire platform. The original spec was focused more on the BMC and securing the code that comes up when the platform boots up. But now this extends to also the peripheral devices like network cards, SSDs, GPUs, and so on. So the specification allows for that. And we're starting to see interest and even adoption for extending Cerberus into these peripheral devices. So this is great progress, driving that open standard across the industry. The second update on Cerberus is that all Project Olympus motherboards now support Cerberus. So for all the specifications that are out there and the hardware that's coming on this front, it will be secured with a hardware root of trust right from the beginning. So that helps to advance the state of the art in security in the industry too. On the second project that we announced last year, Project Denali, so we had 15 companies participate in the joint development forum for Denali. And these companies all worked together over the last year to finalize the Denali specification, the 1.0 specification. This specification addresses a lot of interesting scenarios like append-only streams, zones, and so on. And a majority of this specification will be contributed to the NVMe group. So this is also a good example of bridging across multiple organizations in the industry. The innovation happens here in OCP, and then as it matures, we start working with other groups in the industry to bring it all together. The specification, the 1.0 specification also addresses a lot of usage scenarios outside the cloud. You can see there's enterprise arrays and IoT and so on. Now, one interesting thing about the 1.0 specification also is, give me a second here. So what you see here is a prototype for a reference Denali SSD. This is not a production prototype, it's a reference prototype. But what we believe is that by implementing Denali in this sort of a prototype, we can reduce the cost of the SSD, the non-NAND part of the SSD by up to 70%. So, there are several companies that will be announcing in the coming weeks and months products based on the Denali specification. All right, so let's get on to the second part of the presentation. Let's talk about data. So it is no surprise that the amount of data around us is growing. Yeah, wherever you look, there are new devices that are being deployed, IoT, with the advent of 5G and in a cloud, there's data all around us. And this proliferation of data needs to be handled across the entire life cycle. Where is the data coming from? There are three. This is a study from IDC, and it's a very nice paper. I would highly encourage you to read it. And what they categorize in that paper is to say that there are three key areas. Data is usually generated at the endpoints. The endpoints could be like phones and IoT devices and so on. It makes its way to the edge, branch offices, cell phone towers, where it could be pre-processed. And then eventually it goes to the core. The core is it could be private data centers, cloud data centers, and so on. And the data lifecycle has a way of going back and forth, though. The data that's processed in the cloud can be, you run deep analytics on it, you take some decisions on it, and the data could flow back out. So there is what IDC calls a global data sphere. And what's interesting is that the amount of data that is growing because of these trends is just huge. And you can see that what we did was we put a little counter to show how much data will be generated by the year 2025. And the number that IDC projects is 175 zettabytes. Now, a zettabyte is 21 zeros, one followed by 21 zeros. And just to wrap our minds around it, if someone was to take 175 zettabytes of data and print it on a standard DVD, the stack of DVDs would be able to circle the Earth about 200 times. That's how much data we're talking about in the year 2025. So that brings up the obvious question, how do we store all this data? How do we process this data? Do we even have the supply capacity in the industry to be able to manage this data? Now, again, the same IDC study also goes over the capacity picture, looking out into 2025. And you can see that no matter what type of storage technology you use, we will just not be able to keep up with this data deluge. Right? The data from the data growth on the previous slide was growing by 6x, from about 33 zettabytes today through 175 zettabytes in 2025. But the storage industry cannot grow that fast. So that leads you to believe that there's only two ways we can handle this data growth. One is, well, if you can't store all the data, you have to drop the data. You maybe do some pre-processing, and you store the analysis, and you drop the data. The other way is to be more efficient at data management and data storage. And that's what we'll talk about here in this presentation today. So I'm pleased to announce a new project that Microsoft is contributing to OCP, and we are calling this project Zipline. The project has to do with coming up with a highly efficient way of managing data storage and efficiency. It's based on, I'll go through this in more detail. It's based on a new standard and implementation of how we manage data at scale. So the first thing about Project Zipline is it's a compression standard. That's at the heart of Project Zipline. It's a brand new compression standard. And that compression standard is targeted for what I call legacy and modern data sets. Legacy data sets meaning typical things like application logs, system logs, and so on that get generated when you're running operations. And modern data sets, a good example is all the new IoT telemetry and sensor data that we are getting into, especially as we go into this new digitization aspect. So we wanted to have a compression standard that could address both types of data sets, covering edge to cloud. The second unique thing about this project is that it's not just a new compression standard. There are a lot of compression standards out there. The unique thing here is that this compression standard was designed to take into account the entire system stack, the software implementation, the algorithms, and the hardware implementation as well. So by looking at this at the systems level, we were able to achieve a level of efficiency that is just not possible. Now, the third one is the key thing that I'm excited about. So here, this is the first time, to my knowledge, that we are able to achieve compression without compromise. And what that means is hitting the three important vectors. You want to get a high compression ratio. You want to get a high bandwidth for processing the incoming data stream while you get that high compression ratio. And you want to have extremely low latency while you compress and return the results, right? Now, I don't know of any other compression standard implementation that achieves all of these three vectors together. That is what's really unique about this. And the very possibility of doing all three together just opens up a whole new set of a whole new world of where can we use this technology. And I'll go through that in some more detail. First, let's take a look at the compression gains that we are seeing. So what you have here is three cloud data sets. These are all Microsoft internal data sets collected from things like system logs, application logs, some of the telemetry that we use for our data centers and the like, and IoT and so on. So they're all internal data sets. And when we used Project Zipline compression on these data sets, we were able to see anywhere from, you could see right, like 96% compression to 92%. Even compared to the existing algorithms, on average, we'd see about a 20% better compression ratio than other similar compression algorithms. And this is just on the compression ratio. Now, today, what we're announcing is open sourcing Project Zipline for the benefit of the open source community, and also to drive this as an item that everybody can innovate on together. The first aspect of that contribution is the compression standard and the specifications that go with it. This allows us to define the formats in which the data needs to be encapsulated for the compression. The second aspect is the hardware architecture for how to implement this compression algorithm. Now here, if you've done hardware designs, you start with detailed hardware specifications, pseudocode, microarchitecture diagrams, and specifications. So we're contributing all of that. But the third one is what excites me the most. For the first time in OCP's history, Microsoft is setting a new precedent now by contributing the Verilog RTL. This is the silicon design language for implementing this compression algorithm. And there are several unique things we did on this compression standard for the implementation that allow us to get that high bandwidth and low latency. It is all encapsulated in that RTL implementation. Now, there are several companies in OCP and the industry that will find this very useful, I believe. They can take this RTL and encapsulate that as an IP block. They can tune the algorithm implementation to fit different types of usage models. For example, if you want to do this on the edge, you probably care more about power and less about performance. If you want to do it in the data center, you care more about performance. Power is manageable, and so on. So it gives you a wide range of flexibility to tune the implementation accordingly and to package up the IP. So what we want to do here is to open this up to the industry so that we can seed the ecosystem to build on top of this standard and also take the implementation. It makes it frictionless and seamless to integrate this into a variety of silicon products. Just looking at some examples where the industry could benefit from this. These are just a handful of examples, but I could see this go into SSDs, into IoT applications, cloud migration, even CPUs. And to that matter, we have gotten tremendous support from our ecosystem partners on support for this new standard and implementation. You can see this ranges anywhere from CPU providers to EDA tool companies as well, and everything in the middle, storage and networking companies. So getting this wide set of support from the industry is crucial to drive the implementation of this new standard. And it seems like we are well on our way to do that. And once we get it out in the OCP community, there'll be even more people who will be interested in this and able to drive it to the next level. We have a short video to show on the benefits of this new standard and implementation. So let's take a quick look. I'll be back in a minute.
Azure has been growing exponentially worldwide. Every single bit of efficiency matters. They've estimated that there's about 33 zettabytes of data in the data sphere today. And as far as data that's stored, they estimate that about 50% is going to be stored in hyperscale public clouds by the year 2025. As the cloud scales, as data processing becomes more critical part of our everyday lives and everything we do, the ability to process that efficiently is more important than ever.
Innovation in our compression algorithms have allowed us to better utilize our storage platforms and capacity.
We've been able to get higher compression ratios, more throughput, and lower latency than the other algorithms.
Enhancements like this can lead to direct customer benefit. The potential for cost savings, for instance.
Broadcom, partnering with Microsoft and others in the OCP community, allows us to get insights that help us align our products with industry needs.
Access to petabytes or exabytes of capacity in a cost-effective way could enable new scenarios for our customers.
When you think about the overall data-centric transformation that's happening, it's critical that we enable the industry with the right solutions to move, store, and process a wide variety of data across a wide variety of use cases.
You can't say that innovation is all coming from one place. It's going to come from everywhere. Open source ecosystems are fueled by contributions, the collaboration across the community. We take the designs for our servers in our data center and contribute them to OCP. This contribution is unique because it's the first time anybody's contributed RTL. Hardware manufacturers can take that design and go directly and produce chips that they can sell to customers. The whole ecosystem can take advantage of our innovations, and we can also take advantage of the contributions they make to the designs.
Open standards are really vital for the entire industry. Intel and Microsoft have had a deep collaboration that's really been cloud focused. We're really excited about Microsoft taking a leadership position here and really contributing their overall compression format to the open source community.
The value of XP10 to OCP is primarily in two areas: interop and cost. Lowering storage cost is good for everyone. Having an open source standard allows the customers to compress their data in one data center and then transport it and be able to decompress it anywhere else.
Having a company like Microsoft, which is seen as a leader in the industry, can create a center of gravity. With us contributing designs, especially something like RTL, as setting a precedent, hopefully others will follow that precedent, and we look forward to seeing the kind of interesting designs that are going to come back from other participants.
So what do people think? All right, thank you. No, like I said, I'm super excited about this new contribution because it sets not only a new precedent for contributing RTL, which I hope other companies will follow and evolve OCP into a deeper level of engineering down to the silicon level. But it also sort of expands the scope of OCP to be more systems focused, all the way from the rack server design down to technologies that are at the very core of the evolution of the data. In addition to that, I just want to give a quick update on the other areas where there is a lot of open collaboration happening. The theme for OCP, as Mark mentioned earlier, was open and together. And it's important to highlight that there is a fantastic amount of collaboration happening in the OCP community. 3 of these examples are up here. We have been working closely with Facebook and Quanta to start to understand how to take the best of Open Rack technology and Project Olympus technology and start to find a blend where we can mix and match the building blocks. So for example, a motherboard from Project Olympus can be adapted to Open Rack and vice versa. So that way, it expands the ecosystem for the options available to customers from OCP offerings. The second one that we've been working closely with Facebook and Baidu is on what we call an open accelerator module. Essentially, the challenge here is that as we enter this new world of AI, and there are so many different types of AI silicon that are coming, how do we come up with an interconnect standard for that? So there'll be more updates on this later. And the third one is also to do with evolving the standards to deal with the new challenges that the hardware industry faces. With the slowdown in Moore's law, with the slowdown in Dennard scaling, the power density has been going up. It's very common these days to find CPUs with north of 200-watt TDPs and AI accelerators with 300, 400, and sometimes even 500-watt. How do you cool these servers? How do you cool these designs? It requires a new way to find out how to drive that efficiency in cooling. So the OCP Alternative Cooling Committee, of which Microsoft is one of the contributors, they're figuring out different techniques and evaluating what is the right standard to drive in this area, like heat pipes, cold plates, immersion cooling. There are some cool demos on the show floor today, so you might want to go check that out. To find out more information, yes, please go to the booth. There are several hardware samples and prototypes there. There are demos that you can see and learn more. There are several talks today and tomorrow that you can attend to find out more. My buddy Dave Maltz will be on stage here at 10 o'clock to talk about the contributions to Sonic, which is the open source Swiss software, so you can learn more about that. There are specifications and now source code also available on the OCP GitHub repository. So I hope you'll find all this information useful, and I look forward to a tremendous OCP 2019. Thank you.